Hello everybody, this is Yakov Fain with Farata Systems. As you can see from our site, we are a consulting company that develops various enterprise applications using different software, and Java, of course, is the main software for the server side. On the front end, we are using different technology, and in particular, we are using HTML5, and this is our book that we are about to finish. Actually, the drafts of the books are finished, and you can read the drafts for free over here, enterprisewebbook.com. This training is sponsored by Farata Systems, and we hope you'll like it. This training will consist of 18 video lessons. 18 video lessons will include core programming in Java. We'll start from scratch, introduction to Java. And we also include a section called Java EE, Introduction to Java EE. Java EE means Java Enterprise Edition. Every week we're going to be publishing one video, and all these videos will be available for free. Those people who want to enroll and get extra support, such as my feedback, you want to submit all the homeworks, then you are welcome to purchase participation in these additional technical support for this course. The information about it is on our site. It's on my blog, yakovfain.com, on faratasystems.com, of course. And we hope you enjoy the training. Who am I? Why am I qualified to teach you Java? I work as a programmer for many, many years. And in particular, I work with Java for 15 years. Java is my main language. I've been writing different applications, working for different enterprise clients. I've been writing many technical articles on Java. I've been publishing books, authored and co-authored. And in 2005, Sun Microsystems, the original owner and author of Java language, they nominated and awarded me with a very honorable title, Java Champion. Only about 150 people around the world have this title. And speaking of books, this is a book that we will be using for this training. I wrote this book probably 3 years ago, maybe a little bit more. And this book is our textbook for this training course. It's done as a set of lessons, and when I will be giving you homeworks, the homeworks will come from this book. Also, at the end of the book, as you can see, there is a CD. I recorded videos, short videos for every lesson, illustrating specific topics or subjects that are covered in this lesson. So if you're planning to study using these video lessons, you need to get this book. You can get it on any bookstore, including online. A printed version, you can get an e-version. Just make sure that wherever you get it, it has the supplement, the video lessons recorded by me. By the way, if you have a subscription for Safari Books Online, it's over there too, as far as I remember. What else you have as materials? What other materials we will use during the course? I have slides, presentation slides for every lesson. And besides the slides, I created a website over here on code.google.com/p/practicaljava. This is a place, this is a supplement for this training as well. This place is used not only by me, but other instructors who are using the book and teaching the course are using this place. For them, under wiki, I publish all the slides. So all the slides that I am going to be using in this course are available over here. You can download each of them. The only advice I can give you, just download the copy from here right before you're planning to study any particular lesson. The thing is that once in a while I am revisiting these slides and I am updating them to put there the latest and greatest information. But all slides are there already. Also, on this site, in the download sections, there are homeworks. Every homework is over there. that I was giving my former students. I used to teach, and I still can teach this class in the classroom or online in real time. If you're interested, we can do that. But if you are planning to use just these lessons, the homeworks are here. I am not trying to tell you that you have to cheat and not do the homework and just come here and look at them, but we know how it works. Sometimes you get stuck and you want to move on and you don't know how to proceed and you need some help. So you can obviously download the homework for any specific lesson and pick and see how it's done over there. Some of these homeworks I did myself and published them. Some of them are done by my former students. And in some cases, you can see more than one version of the homework for the same lesson. For example, what do we see? If I see lesson 17 solution 2, it means that there is somewhere lesson 17 solution 1. And in some cases, you can even see lesson 22 solution version 3, lesson 22 solution version 2. So each of these are different versions of the same homework. So hopefully you'll find this practical and useful. Also, speaking of the book, of the textbook, this book was published by Rock's publisher, and the book has its own site. We're going to be using this site mainly to download some sample code that comes with the book. In many cases, during the classes, in this particular case, you can see we will start from lesson 3. I already have code samples. Lessons 1 and 2 are kind of introductory, and we will cover the materials from these 2 lessons today. Lesson 3 is the one that starts with some exercises and code samples. So in many cases, we're going to be downloading the samples. I will ask you, download the project for lesson 3, 4, or 5, or whatever else you want. And you will import it into your integrated development environment. We will be using Eclipse. And you will try to test these examples, try to read them, review the code, and analyze the code, and stuff like this. Besides that, why this site can be useful, there is a section called errata. Obviously, we are trying to not to make mistakes, but sometimes it happens. And after I tested everything, after technical editors of the book tested everything, still the errors are creeping into the book. And readers and myself, after the book was printed, we found some mistakes or errors or typos. And in this section, you can find whatever we found today. So if you are looking at some example on a page and it doesn't seem right to you, or maybe you're trying to test the code but it doesn't work, make sure to visit this errata section. Maybe we already noticed this and published a fix for the code, or maybe fixed the typo. Hopefully the future prints of this book will not contain these typos. At least this is what publisher says, that the next print runs will have all these reported errors fixed and cleaned up. By the way, if anybody is reading Spanish, this book was translated last year into Spanish language. So if you like Spanish better, or if you're a native speaker, so you can see if the book in Spanish will be easier for you to read. That's about it. That's about it for the introduction for the course. As I said, I'm planning to do 18 lessons for this course, record 18 video lessons. Every week I will be publishing a new one. And if you will be consistently doing the homeworks and studying materials that are suggested during this course, I am sure that you will succeed and you will master this language. When I say master, you cannot be super duper guru, of course, after watching these lessons, but it'll give you a really good start and a good set that practical programmer needs to know today for working on a team, on real world project. Next, let's switch to slides. I'm going to be using slides, and I showed you where you can find them. In these slides, I also use additional materials, and I added links to the additional resources. I highly recommend you to visit those resources on as needed basis, of course, but try to stay focused. There is so many information, so many materials published on Java, and if you will try to read everything that is available, it's just not possible. Try to stay focused and work along with me and read the materials that I recommend you. Of course, you will be finding something else that is useful, but for now, during this course, stay focused on what I suggest you to read and study. So let's start. Today we're going to be writing the first simple program, Hello World. Hello World is a type of program that typically people use to start learning a new programming language or maybe a framework. Why? Because if you can write a program that can print or display on the screen the words Hello World, it means that you have downloaded the proper software. It means that it's configured properly. It means that you know how to write this program, and you know how to start this program. So this is our goal for today, to write 2 versions of Hello World, and we will definitely do it today. But first, we will start with general information about the Java language and why do I like Java, why it makes sense to study Java. This slide is about the book. We already talked about it. So why learning Java? Some people will say it's old, it's out of fashion. Is it so? Is it old? Yes, it is old. The language was created in 1995. The father of Java, as people call him, James Gosling, created this language. Original version name of the language was Oak, and then it was renamed into Java. Of course, he was not the only one who was creating the language, but he was the lead, and that's why we call him the father of Java. So today is what? Today is the end of January in 2014. So the language is 19 years old. Of course, for the language is pretty serious age, but the Java language does not get rusty old, and I'm definitely sure that this language will continue serving me and will continue bringing bread to my table and will feed my family pretty well. Why I think so? First of all, there is so many applications for the enterprises written in Java. The code base is humongous. Second, there are 9 million of professional Java developers in the world. When I say professional, I mean they make money for writing programs in Java, not those people who just decided to play with it a little bit. And the other thing is Java is open source. So the source of the language itself is available from day one, and the community is huge, and people around the world, when they write their programs in Java, when they run into an issue, they fix it and they publish the solution online. Lots of blogs, lots of technical articles on this language. And if you will run into an issue, most likely, I'm pretty sure actually that somebody else ran into the same issue before and the solution is published online. So you are productive because of all that when you are developing a new project. There is the labor pool of people who know Java is also pretty large. If I'm a manager of a new project, if I'm considering what language to start to use for my project, of course I have a choice. But the very fact that there are lots of senior, smart, seasoned Java developers gives me some safety net and I can be sure that if my superstar Joe Smith will decide to quit the company and leave the team, then I'll find somebody who knows Java. This is not the case for many new languages that are fashionable, but they are pretty young. Community is not that great, and there is not too many people who know these languages. So why take a risk? The other important thing is that the Java language is not only the language. It's of course, actually, this is wrong. Java is a language, but there is an ecosphere. There is an environment. There is a universe with a bunch of tools, frameworks that is written around Java. And the most probably important piece of software that makes Java popular and stable is Java Virtual Machine itself. The code that you write in Java is going to run inside Java Virtual Machine, or as we call it, JVM. JVM can be used for running programs written not only in Java, but in other languages as well. For example, this hot language Scala is compiled and you run it on JVM. What else? Groovy, you run it on JVM. So JVM is a platform for many languages, and it's pretty stable, works well, it's scalable, which is important, especially important for enterprise applications that have to serve multiple concurrent users, thousands and thousands of users. It's scalable. If one server is not enough, you can horizontally scale and create multiple parallel servers, cheap servers. You can go on cloud and use one of the cloud solutions with Java. Pretty rich and stable platform. So I'm pretty sure that it will last for many years to come. This is not to say that other languages are bad. Of course not. The more languages you know, the better programmer you are in your main language. That's given. But my main language is Java, and it'll stay this way for a while. Even though I am looking at other languages, in particular, my new pet language is Google Dart. Dart from Google. Really nice language, and maybe one day I will create a training course on Dart. There is, on this slide you can see there is a so-called TIOBE index, and the link is there. They rate languages, the popularity of the languages, and they publish, I think they publish it monthly, like a chart of languages based on popularity. And Java was for many years number one, and now it's fluctuated between number one and number two. I think C, I don't even remember what else is now number one. Actually, why won't we just take a look now? Let's see, where is Java? How Java is doing these days? HTTP. Let's see. TIOBE index for January 2013. Number one is C. Java is number two. I believe that C moved a little bit up because of this programming for smaller devices. There's a huge number of smaller devices, mobile devices, so maybe that's the reason why C is number one now. But Java is number two, as you can see. So we are pretty safe in this area. Going back to the slides, what else is important and why Java is good? Look at this bullet. The same program can run on different platforms. This is very important. There was a promise, write once, run everywhere. I wouldn't say that this promise was fulfilled 100% for Java, but it is pretty much true still. So you write a program, and the same program you can run under Windows, you can run it under Mac OS, you can run it under all these flavors of Unix, Linux, the same exact program, which is very important, especially now when people are trying to use software on a variety of different computers, and not even computers, but other devices. For example, Android is a pretty popular operational system for smartphones, and you write code in there in Java. There is a slight difference in libraries that you need to use for Java, but the language is the same. It's Java. I'm using Mac computer, MacBook, and I'm using Mac OS, of course. And I don't even know what computer you are using. You can study Java using my training on Windows, on Unix, on Mac OS, of course. It doesn't matter. It's the same set of exercises, the same source code for everything. You will see it on your own. How it was done, how it was achieved, I will explain you pretty soon. So how was it? Let's talk about some terminology first. Let's be done. Let's do it before we can proceed. There is something called JDK and there's something called JRE. JDK stands for Java Development Kit. JRE stands for Java Runtime Environment. Let's start with JRE. You need to know that when you write a program in Java and you want to deploy it, you want to install it somewhere, you want to give it to your user to install it on their machines need something, not only the program, but the Java runtime environment as well. So you start Java runtime environment, it brings up Java virtual machine, and Java virtual machine JRE loads your program which runs inside the JVM. That's why users will need JRE installed on their machines. Software developers, Java developers like you and me, need JDK, Java Development Kit. It includes everything that is in JRE, plus it has something else. It has tooling required for developers. In particular, it has Java compiler, because you will write the source code in Java, but so this source code will be compiled into a different language. Into what? Into so-called bytecode. And this is something that makes Java different comparing to languages like C or C++. What's the difference? The difference is that if you will compile language written in C language, the compilation will be done into machine code for a particular platform. For example, if you will write program in C language under Microsoft Windows, and if you will compile that language on that machine, the compiled version will be specific for operational system Windows in particular. These languages like C or C++, they have direct access to hardware. For example, this particular compiler will know how to work with the files on the file system, say on Windows. And you're going to be using in your program, you're going to be using specifics of working with files on that particular operational system. Or if you need to print, everything is specific to the device. In Java, it's different. Java program is compiled not in the machine code, but in the bytecode. Bytecode is like, it's something intermediary. It's in something intermediate in between the source code and the machine code. But bytecode, optimized bytecode, is something that is needed by JVM to run this program. So JVM runs bytecode. When the program loads into JVM, this bytecode gets recompiled into machine code, but the initially compiled version is in bytecode. When you write a program, this program is compiled, and when you run it, it gets executed in a shell, so to speak. This JVM is, think about it as like a shell, like a balloon, which is the same from the perspective of the program that runs in there. It's the same, regardless of what operational system you use. So if I write a program that needs to read a file, The code will be the same, and this program will run in JVM, being that in Windows or in Linux or in Mac. I will, when I say I mean the program will say, I want to read a file, but the program will not reach out to grab the file. It'll tell the JVM, please read for me the file. That as far as the program can see, JVM. Of course, JVM in turn would be installed. You'd be installing specific JVM for the platform, of course, and JVM knows how to work with file system on Windows or maybe it's Linux, and it will read the file accordingly. But the program itself, it doesn't know how to read the file from any particular operational system. So by having this shell, by having this middleman, this JVM, we kill many birds with one stone. Basically, we are saying, don't bother what the operational system is. Your program will run inside JVM, which is the same from your perspective. That's why that statement was even born. Write once, run anywhere. Why? Because the JVM anywhere is supposed to be the same, exactly the same. Speaking of Java, there are different sets of Java, or different distribution, I would say, of Java. Java SE and Java EE. Java SE, it stands for Java Standard Edition. Technically it's core Java. Language itself with a bunch of useful libraries, of course, but it's not written specifically to run on server or on client. It's implementation of the language plus a bunch of useful libraries. On the other hand, there is a distribution called Java EE. Actually, it's not only a distribution, it's a specification, I'd say. There is a specification that first describes what has to be included in Java SE. There is a specification that describes what has to be included in Java EE, Enterprise Edition. Formerly, it was known as J2EE. And of course, somebody implemented it. Who implemented this Java SE? The owner of Java, so to speak, is Oracle now. It used to be Sun Microsystems, then Oracle purchased Sun, and now Oracle makes new releases. On the other hand, there is a open source version of Java, Open JDK, and they also, by the spec, create this their version of Java. We are going to be using Oracle's version of Java during this course. Java EE, it's not about core Java. Java EE includes everything that is included in Java SE, plus on top of that, it includes libraries supporting different technology, how you can write software in Java for the servers, mainly for the servers. In particular, as I put it over here, Java EE include support of servlets, Java server pages, Java server faces, enterprise Java Bean, Java messaging service, and so on. Java EE, it's a set of specs, or as we call it, set of JSRs, which each of them describes a particular technology. We will be learning many of the Java EE players, so to speak, or modules or technologies later in this course. For now, just let's remember that all Java programs run inside JVM, being that Java SE or Java EE written programs, but everything is inside the JVM. Now comes installing of the JDK. On this slide, I show you installing a snapshot for installing on Windows, but installation is pretty straightforward regardless of what platform you have. On Windows or on Mac, installation is pretty easy. You download on Windows executable, on Mac you download DMG file, you run it, and a couple of minutes later, not even 1 minute later, just hit next, agree with all defaults, and Java will be installed on your machine. Very simple. Very simple. And where do you get it? from? Let's see. Where do you get it from? You get it from actually, even if you will just Google Java download, you will find this site pretty easily. You see it now on your screen, Java SE download. And over here, as you can see, it says Java platform, and underneath it gives a number. It gives a number 7U51. This 7U51 means that we work with version 7 of Java, and U51 means update 51. Java 7 was released originally probably 3 years ago or so, and since then all these minor changes, maybe security holes, security fixes, actually security holes are being found, and security fixes are applied, or maybe some other bugs, and once in a while Oracle releases new updates. The latest updates for version 7 is update 51 as of end of January. So that's what we are using here. And in March of 2014, basically maybe in 6-7 weeks, Oracle promises to release officially Java 8. Originally, I was planning to start from the very beginning with version 8, JDK 8, but as of now, it's so-called developers preview version. Then I decided not to take chances and not to risk. What if there are some bugs that will stop you? So I decided to wait till the official general release in March. When Java 8 will be released, we'll install it and switch to that compiler, and we'll be covering features of Java 8 as well during this course. So you click on this button, download. It'll take you to the next screen, and you will have to pick the distribution for your operational system, whatever you're planning to use. You'll need to accept the license agreement and download one of these files. In my case, I downloaded the version for Mac OS is DMG. If you're in Windows, download Windows x86. Even though you can do x64, I've heard people had some issues with it, but maybe you won't have an issue. So anyway, pick up the versions that you like, download it, and install it. Installation is simple, as I already told you. So after you install it, it'll install your JDK in some folder, in some directory. On the slides, as you can see over here, I created this slide when it was JDK 7 and update 2. By the way, when we say Java 7, in some cases you can see 1.7, it's the same thing. As you can see over here on Windows, it was installing itself on other program files, Java, JDK 1.7.002. Underneath, you will find several other directories. One of them will be bin directory. Bin directory is a directory where the Java compiler is, where Java runtime is, and some other utilities are. You need to have this bin directory in the path on your computer, in the path variables on your operational system. This way, when you will go to a directory on the disk, you will open it up and you will decide to run the compiler in Java. No matter what directory is, it'll know where to find the Java compiler, or maybe Java runtime, whatever you will plan to do. So you need to add that folder to the bin directory on your, to the path system variable on your machine. If you will follow this link, you will see how you can update the path system variable. When you will install Java on your machine, you need to make sure that you did everything correctly, and you need to make sure that when you enter the word Java, it'll run or start the correct version of Java. The thing is that you may have more than one version of Java installed on your machine, so we don't want to assume that we have the latest Java version and actually we are using the older one. So how to do something like this? I'm open the terminal window. On Mac it's a terminal window, but on Windows it's a command line window, right? So I opened it up, and where am I? First of all, pwd, it's on Mac and on Unix as well. print working directory tells me where I am. I'm in the root directory on my computer. As you can see over here, it's user Wi-Fi 11. That's my ID on this machine. So what I will try to do now, I want to enter the command as you see on this slide. You see this command down there at the bottom. You see this Java minus version. I want to see what version of Java would I use. As you can see, I have installed 1.7.051. It's Java 7 update 51. So I have the latest version of officially released Java 7 at this point. So this is something that you will need to do to test that you have also the right version installed and properly configured. So I am ready to run my Java programs using Java 7 update 51. Walkthrough. These slides have, in some cases you will run into a slide that is titled walkthrough number 1 or 2 or maybe 3. These are the exercises that I give my students during the class. It's not a homework usually, but it's something that people do during the class. In our case, we have a special situation. You just watch the video lesson at your own speed. There is no classroom, and in many cases, I'm going to be doing the assignment that I give in the walkthroughs. I'm going to be doing them myself. Not in all cases, but in many cases. But you, of course, you need to do all the walkthrough as well at your own speed. In this case, in this walkthrough number 1, I am just asking you to download and install Java SE version 7 update 51. I provided a link, and basically there is nothing special. I just show you that website, and you need to type Java version. So this walkthrough, consider it done. At least I just did it in front of you. Now let's start writing a program. We need to write a program, and as I promised, we will run a program that will display on the screen hello world. But first, the big steps, the major steps that you will need to go through if you are writing a program in Java. First of all, you need to write this program. As you see in the first bullet, write the program and save it in a file with a name that ends with the name extension .java. What you need to remember that Java is case sensitive. And in this particular case, as you can see, I named the file hello world Java with capital H and capital W. Inside of that file, we will write a class. In Java, everything starts with class. Not everything, but most of the stuff. I will name that class also hello world with capital H and capital W. Java is case sensitive language. So if you'll make a mistake, for example, if you name the class with hello world with small w, for example, and the file is named hello world with capital W, there will be a problem. You will have an error. The runtime will say, I cannot find the class. Where is the class? You look at it, it's right there. No, it's not the same class. If it's small w versus large w, it makes a big difference in Java. Just keep it in mind. But anyway, you need to write a program and save it in a file with extension Java. Where you are going to write this program, it's up to you. You can use any plain text editor. You can use VI on Unix if you like it. You can use Notepad on Windows. I'm using, on Mac, I'm using Sublime Text. I like that editor. Any text editor that you like. Enter the text of the program and save it in a plain text mode. Not a word processor, of course. Not Microsoft Word, forget it. But a plain text editor. Save it in a text file, and you have a program written in Java. This is the source code of your program. Next step is we need to make sure that the program compiles. We need to compile it to convert the program from the source code into another file which will have the bytecode inside. So Java C is the program that is compiler. It'll compile your code into bytecode. So what you will need to do, you will need to open the command prompt window or terminal window and enter in there javac space hello world.java. After you do that, you will see that the second file was created with the same name as the first one, hello world, but the name extension will be not .java but .class. I'll show it to you in a minute. So if everything is fine, if there are no syntax errors in your source code, you will get as an output compiled class. If you have errors, you will see errors on the screen and you'll need to fix them before it'll build for you the compiled class. When the class is compiled, and one other thing is important, that class must have special method. Think of it as a function. Method main is something that makes a class runnable. If you have a class with multiple methods and one of them is called main, then this program is runnable. So if you have a program with a main method, then you can run it. So the third step is you enter on the command line java space hello world. Please note, it's not javac at this point, it's java, because I don't need compiler anymore. I need Java runtime. So Java starts the JVM and load the hello world program and executes it there. So 3 steps: write a program in the source code, compile it, and run it. And on the slide number 10, you see over here a snapshot of the screen. This particular one was in Windows. Javac hello world Java. After that, I enter command dir for directory, and it shows me that I have in the directory hello world.java and hello world.class compiled version, right? And then I do java hello world, which runs the program, and that program in particular, it printed hello space world on the screen. So that's the whole process on the command line. I'll do it now in front of you. What will we put in that program hello world, and how the program in Java in general looks like? What has to be there? In a program, we are using, of course, very simple program in here, but just for now, just remember there is something, probably the most important notion in Java or term is class. You define a class, like you have different class, like you have class animals, for example, right? You have class which describes what do you want to do. I want to create a class that will do something, and maybe it'll have some properties. Like a bird can fly, and it has some properties, like how many eyes it has, how many legs, and so on. But in our case, we just want to create a class hello world, which will have one function. It'll know how to print, it'll know how to start the program, and it'll know how to print hello world. When you write a class, you give it a name and you open a curly brace. Every opened curly brace in Java has to have a corresponding closing curly brace. Inside this class, by the way, I entered also the word public, meaning that other programs can access it easily. What is a data access and what are these keywords, public, private, protected? I'll explain in the future lessons, but for now, just do it. Keep it, just write the word public over here. Now, what's inside of this class? I have a method main. Whatever word you have in front of open parentheses, it's the name of the method. Before the name of the method main, you have different qualifiers. We are saying it's a public method, which means that you can call this method or invoke this method from outside of the class. Static, it has a special meaning that multiple instances of the same object can reuse it, but it's a bit too early to go into detail what static is. Void means that the method main does not return any value. So it's not the case that we calculate something in main and return it back. The calculated value. No, it doesn't return anything. So what it does, if it doesn't return anything, it just prints. it prints on the system console the word that I put in here in double quotes. In this case, I wanted to print hello world. How do I print it? There is an object in Java called system, and in system there is a special print stream variable of type print stream variable called out, and that print stream has the method, multiple methods. One of them is println, print and line feed at the end. So it's of course it's a very quick overview, but for now just trust me that this is how it's supposed to be done. Also, when you write a method, the first line of this method we call a method signature. The last line of this slide, look at this. Public static void main and arguments inside the parentheses. Again, what are the arguments? I'll explain you in the future lessons, but for now just keep it this way. So this is the signature of the main method. If a class has a main method with this signature, then it's not just a class but a runnable program. So this is what we will try to do. Let's see. What I will do, I will create a directory. I think it's going to be in the walkthrough number 2. I will create a directory called practical Java. Let's see. Yeah, it's right there. Next slide. Walkthrough number 2. I will create a directory called practical Java. In there, I'll create a subdirectory lesson 1. Then I'll open up a plain text editor, and I'm going to type in the text of this hello world program and save it there in this directory under the name hello world.java, right? Then I will open up a command window. Actually, I already opened it. I will cd into that directory lesson 1. I will compile and run this program. Compile with Java C and run with Java. So let's do it. I am in the command line. Sorry, I'm in the terminal window. Where am I? I'm in the root directory, right? So make directory practical Java. cd practical Java. Where am I? pwd inside practical Java, right? Make directory lesson 1. cd lesson 1 ls. It's like dir in Windows. Show me what's in there. Nothing. It's empty, which is good. This is what we want. Now I'm gonna open a text editor. As I said, I'm using Sublime. On the right hand corner, I'll say that I'm gonna be writing text in Java. It's not just a text. Public class hello world. Open curly. See, this Sublime editor is pretty nice. It helps me. It's even printed the closing curly brace. So this is the very beginning. Right now it's an empty class. It has a name. I can save it. I can even compile it, but I cannot run it. It has nothing inside. Let me save it first, at least. File. Save as. I want to save it under practical Java, under lesson 1, right? And I want to call it, as we agreed upon, hello world. Hello world.java. I saved it already. Right? Now, I want to create a new method inside. Public static void main. What else in there? Argument. An array of strings. Again, couple of curly braces. As you can see, every open curly brace should have the closing one. So in this case, opening curly brace for the method body, it has closing curly brace for the method body. See, this method ends over here. I could have created another method in there as well, below, but we will have only one for now. So what else I need to do? I need to write a statement that will actually print hello world. System out println hello world, and let me put a couple of exclamation points in there, exclamation point, sorry. Done. Command S, save the file. Let me go back to the directory. It used to be empty, not anymore, I guess. See, it has hello world Java now. What I will do now, I will compile this class. Java C, hello world Java. No errors. Good job. ls. As you can see, I have a new file now, hello world.class, which is a compiled version of hello world.java. I didn't have any errors. See, no news, good news. When I compiled the class, it didn't give me any specific confirmation that everything is great, which is good. If I would have an error, it would definitely warn me about it. On purpose, let me create an error. See, in Java, every statement has to be and has to have at the end, it has to have semicolon. What I will do, I will remove this semicolon and save it. Command S. Let me go back and try to compile it now. I have an error. See, it helps me, it prompts me telling that I have a semicolon at the end. I need a semicolon at the end, sorry. So let me fix it again. Save and recompile. Now it compiles well. Now let me run it. Java hello world. Now I'm running the program. As you can see, it works fine, and it printed me on the console hello world with exclamation points. So here we go. We created the first Java program, and this Java program prints hello world. We wrote the program, we saved it, we compiled it, and we ran it. So that's a pretty important piece of action that we did. Now let's go back to the slides, and we'll try to do the same thing with integrated development environment. So what we achieved, we compiled and ran the program. Even though there are people who still work this way, they use text editor and command line compiler. The majority of the people use a different environment. They work inside IDE, inside integrated development environment. There are different popular IDEs in the Java world. One of them, probably the most popular IDE, is Eclipse. It's an open source IDE, pretty mature, exists for 10 years, probably more than 10 years. And most of the professional Java developers use Eclipse IDE. There is another very good IDE called IntelliJ IDE from JetBrains, and excellent IDE. It's a bit less popular, maybe because it costs money, I guess, even though there is a community edition for free. And Oracle also has its own IDE called NetBeans. It's not that popular, but it's there, and some people like NetBeans as well. The point is that integrated development environment includes text editor, compiler, debugger, a lot of helps, and pretty much it's a place where you will be spending most of the time while working with Java inside the IDE. Eclipse IDE looks like this, or similar to this picture. It's a workbench, we call it, where you work, and the workbench has so-called perspectives. As you can see on the top right corner, I am now in a Java perspective. Perspective is a set of views. Each of these rectangles is called a view. So a set of these views that are useful for a Java developer may comprise the Java perspective. The set of views that are useful for Java EE developer may be slightly different, but it still will look similar to this, a bunch of views. There is a version control view. It'll look different. There's a view to look at the data. It'll have a different set of views. Sorry, perspective. So there are different perspectives inside the IDE, and you can open up those that are available and that you need. In the middle, you're going to be writing code. It's going to be a text editor where you will type in and change your program. On the left-hand side, you will see your projects and files which belong to your project. At the bottom, you will see different tabs, and each view will show you something else. For example, Problems tab will show you errors, if any. Then you will have a Console tab where you will see the input-output with the for example, in our case, you will see output of hello world over there. Compiler is also not included, but behind the scene it'll run your programs or as soon as you save the text of the programs. On the right hand side there is could be task list, could be an outline which will allow you to navigate faster large projects, or maybe even a large class. Anyway, so there are all these convenient views that comprise a perspective. We also, actually, why talking too much? Let's do it. We need Eclipse IDE, as I said. I'll show you where to get it from. You'll need to go to eclipse.org. And what I want to stress, I want you to download and install Eclipse for Java EE developers. There is a standard Eclipse and there is Eclipse for Java EE developers. Why I want you to download and install this one? The reason is I want you to have Eclipse that is stuffed, packaged with extras. In particular, we'll need them for development of web modules. There is a Web Developers Toolkit, which is packaged with this version of Eclipse for Java EE developers, so I want you to have it right there. The current version of Eclipse is also called Kepler. The name of the version is Kepler. So walkthrough number 3 tells you that you need to go and download Eclipse, and let me show you where you would need to get it from. Eclipse.org/downloads. If you will go to this site, you'll see different versions of Eclipse. Of course, since I am sitting on Mac OS, it offers me to download for Mac, but you can download it for different operational systems. But I want to remind you again, I don't want you to download Eclipse Standard. I want you to download Eclipse IDE for Java EE developers. So download this one and install it. As a matter of fact, installing is as simple as unzipping a file. You will download a zip file of this size, 245 megabytes, as we can see, and unzip it somewhere. That's it. After that, if you're on Windows, you'll go inside and find Eclipse exe and start it. If you're on Mac, there's also a script to run Eclipse inside. So that's about it. So I assume that you download and unzip it without my help. But what I will do now, I will run my Eclipse, which I already created. See Kepler? That's the latest version of Eclipse. It is loading Workbench. It's starting, and now it started. If you didn't have Eclipse before on your machine, you will have a slightly different screen. You will have a screen with a welcome page. Just close that welcome page and and you will see something like I have. Pay attention and up on top on the title bar. It tells me where is my workspace. What is workspace? Technically it's a directory on the disk where all my projects that I work with now will be saved. Projects, files, everything will be inside that directory. So in my case, I named it Java Training Feb for February. If you want to switch to a different workspace, or maybe you want to organize your files, you have one workspace for one client, maybe you work for another project for a different client, you want to keep them on a different workspace, go ahead and do it. It's pretty easy. You can switch from one workspace to another in the menu File, Switch Workspace. As of now, I am sitting inside this folder, and this is my workspace. I'm not going to be switching it. I am in the Java perspective. As you can see, I also have open Java EE perspective because I've been doing some Java EE work. You will not see it immediately when you start for the first time your Eclipse, but you can always open it up. If you will go to the menu Window, Open Perspective, maybe other. Let's say let's assume that I also want a JavaScript perspective. See, it'll open. Now I have Java perspective, JavaScript perspective, and Java EE perspective. So you can have different perspective and switch between them. Maybe you have a project that uses different languages. I'm just showing you where you can open additional perspective. Or I can do a window, open perspective, other. See, let's say I'll be working with Git repository. I can open Git perspective as well. And in here, I would need to configure my Git. Maybe I have on GitHub my source files, or maybe I have source files in Bitbucket in one of these repositories for Git. So I can be in the version control repository looks different than not repository. Version control perspective in Eclipse looks different comparing to Java perspective. What is again perspective? It's a set of views that are useful for doing Java in this case. Let's do Hello World in Java. On the left hand side there is this navigator view. Actually, you won't see navigator immediately. You will see show view. You will see package explorer immediately. I don't want to confuse you. I want you to see exactly what you will be seeing when you open for the first time. This is what you're going to see. You're going to see package explorer. Let's create a new project, file, new Java project. The other way to do this, right click on the package explorer, new Java project. Same thing. I want to create Java project. Say my first project. Pay attention. By default, inside it creates a folder, my first project, inside my workspace. Next, if you have more than one version of JDK installed, you can pick which one you want for this project. Because you may have a client that will say, I know that Java 7 is latest, but in our company we're still on Java 6. So please make sure that the project that you develop will be compliant with Java 6. So in that case, I would select Java EE, Java SE 1.6. It wouldn't allow me to use the latest feature from Java 7, but if the client wants Java 6, they can have it. So in Eclipse, you can use any particular JDK that you want. So I hit next. It suggests me where do you want to keep the source files for the project. By default, it offers me the folder SRC. It's fine with me, I don't mind. Where do you want to have compiled classes, output folder, see bin? So the SRC folder will have the source files in Java that I will write, but the .class files will not be sitting in the same folder like we did in the command prompt, but they will be placed in the bin directory. All right, that's fine. I'm not going to be changing anything. Finish. It created for me my first project. Inside, it created a subfolder SRC for the source files, and it also links to the Java runtime that I have installed on my machine. So this project knows where it is. It doesn't copy the runtime. Of course, it would be crazy to copy the whole runtime for every project, but it knows where it is. Now, I want to create a new Java class, Hello World, correct? Right click on this SRC, new class. You could have done the same thing going through the main menu, of course. So I want to call this class Hello World. Not changing any modifiers here. And look at these checkboxes. I want to check off this public static void main. I want to say, please create for me a boilerplate of the class that will include the method public static void main, because I want this class to be runnable. Finish. Done. It created for me this Hello World class with the method main. If you see a line that starts with 2 slashes, it's a single line comment. It's just a comment that tells me that it was generated. I need to do something over here. I will delete this comment, and I will put system dot. Look at this. I just entered dot. I want to write system out println. I know that what to write, but if I wouldn't know, Eclipse would help me. It knows that, oh, he wants to use the class system. The class system has a whole bunch of different things in there. See all these things? Which one you want? I can pick and choose from here if I don't remember. All right, I want to have out. What is out? Oh, it's a variable of type print stream. What is print stream? It opens me help in this yellow rectangle. And I can read about it right there. So Eclipse IDE helps you. It gives you type ahead help, plus it gives you access to the documentation. All right, so let's say I know that I want out, and I hit dot again. Oh, now it knows. Inside out, there are other things in there. I know that I want println. Let's say I don't. I can just browse and look. And I start typing println. By the way, at any given point, if you want this help ahead work again, hit Control Space. At any point, if you don't see this help and you want it, hit Control Space and it'll help you out. Println. And I want in there, hello world, let's say from Eclipse. Now I will hit Control S or Command S on Mac, or you can hit press the button with the little disk over here. The point is we want to save this code, save on disk. Look at this little asterisk on the tab of Hello World. If you see this asterisk, it means that you have unsaved changes. So Command S and it's saved. Not only it's saved, it also gets compiled. This program is already compiled now. You may say, how come I don't see .class file? Remember when we created the project, we said separate the sources from the compiled classes. Compiled classes are sitting inside the folder, bin folder. But I don't see the bin folder over here. The thing is that this View Package Explorer is not about showing all the folders. There are filters, they hide something, but Eclipse has a convenient view called Navigator. If I go to the menu window, then show view, Navigator. Look at this. Right there, it opened up a new view. It's about the same project, but it shows it more of from the files perspective. Now it shows me that I have which directories and files. These with dots are even hidden files from Eclipse. Inside SRC, I have hello world.java. And inside bin, I have hello world.class. See that? So I didn't lie to you. So I have hello world.java, which was compiled at the minute when I was saving the file. If I had an error, let me on purpose, I will delete the semicolon as if I don't know that it has to be there. First of all, on the left-hand side of this, I will hover the mouse over this red bullet, and it shows me the error. Syntax error, insert semicolon to complete block statement. Now, let's say I don't want to do this. I still want to save it. Let's say I have no idea what the error. I don't know how to fix it. Save it anyway. For tomorrow, maybe I'll go to some guru in our company. They will tell me what's wrong in there. If I saved it just like this, at the bottom you see the problems tab, and in there it tells me that my project has errors. That's the one. If I will double click on it, it'll bring me to the line. Of course, this is a very small program, but imagine a file, a class with a couple of hundreds lines of code. It's useful feature that you double click on the error and it jumps right there to the line which gives you an error. These red little things are also a bad sign. It means that you have an error. Until you fix it, it'll be staying there. So you can look to the left, you can look to the right, you can look down, but you'll see this red stuff which is bad. So let me put semicolon again and there, save it again. Great, we fixed this complicated program. Not only we saved it, it got recompiled. How to run it? Different ways of doing this. Let me show you one of them. right click on this hello world.java. It'll open up this menu and select the option run as Java application. I want to run it as a Java application. If I wouldn't have this main method, it wouldn't run it as a application. Just a reminder. Click. Got it. Look at this. Down there. In the system console, it printed me hello from Eclipse. Let me change it. Hello again from Eclipse. Command S. I can run it again using right click, run as. Hello again from Eclipse. I change the program, I compile it, and I run it again. We'll keep working with Eclipse, and I'll show you different things, different tips and tricks here and there, how to use this environment. But you will see on the slide at the end, I'll provide you with a couple of links where you can go and read about Eclipse, simple tutorial. It's pretty intuitive, but it has a whole bunch of shortcuts, hotkeys. Make yourself comfortable with Eclipse, because you're going to be spending a lot of time in there. I think we are done. We are done for today. Yep. On this slide, you got this homework. Again, to do the homework, if you are planning to do the homework, you need to get this book. And in this particular lesson, I don't ask you to do anything from the book, but in most other lessons, I will tell you, open up the lesson so-and-so and do the assignment from the try it section. See, for example, try it. Every lesson has at the end try it section, and steps would have to be done. So in this particular case, I am just asking you to write a simple program that is not hello world, but it'll print several lines on the console with your address. You don't have to write me your own address, of course, but any address. You need to study all materials from lesson 1 and 2 from the book, from the textbook. Also, create a new project in Eclipse, call it sale, and inside create a new class called friends and family, as if we have sales running in some supermarket or maybe department store, and we want to write a program. I don't want to tell you what this program will do. I want you to guess. Look at it, run it, read it, try to guess what it is about, why it works the way it works, like this. Don't worry, it's not like the rest of the course will be like I'm going to be trying you to guess things, but trust me, you're going to be doing a lot of self-studying. At the end, I give you a link over here for Eclipse tutorial, where you can try to read about this IDE. And on the next final slide, you see this additional read. How to study online. I found this article, or it was originally in Russian. If you are new to studying, to online trainings, it may have some useful hints. Original link is in Russian, but Google translated the translation, and I provided for you a link so you can read it in English. English may be not perfect because it was done by the machine, but still it's better than nothing. And finally, Eclipse IDE Workbench User Guide. This is a product documentation about Eclipse IDE. So you have plenty of reading to do, and I just want to thank you for coming. Thank you for watching such a nice looking superstar like myself talking about Java. I hope I didn't bore you to death, and I'll see you next week. Next week I'm going to be publishing lesson number 2. Those of you who decided to register for the training and participate in the consultations, in the online session with me once a week, I'll see you during the week. But for the rest of you, I wish you good luck. I wish you the best. Enjoy this course, and I hope you will like Java as much as I do. Bye-bye.